All right, so we're trying to find the derivative of this function evaluated at this point and in this direction. So in order to do that, we need to follow a step-by-step process. Technically, they're asking for DUF, but we want to evaluate that at a certain point. So DUF could be a vector or scalar, depending on whether it's at a point or whether it's got variables. So first, what we're going to do is we're going to find u, that's this thing, and then we're going to transform that into magnitude, and then we're going to make that into the unit vector, because we're going to need that for step 2. In step 2, we're going to take the gradient of f. This is the derivative, essentially. It's the partials because it's a multivariable one, so we got to do that. And then we're going to dot that with the u vector right here. That's going to give us the du f. But like I said, so if you have variables, then that's just a vector. Because again, we're taking this dot product here, and if you remember what the dot product is, it's I plus JJ plus KK. And so if that has any variables in it, then it's a vector. But if it's just scalars, then that's just going to be like evaluated at a certain point. All that's just going to be numbers. So it would literally just be like, evaluated at a certain point like that. And then you just dot it with another, number. And then if you add that up, then it's just going to be, like a scalar. So that's what we're looking for. Anyway, so let's go ahead and try to do this. The first step is going to be taking these u and transforming it into magnitude. So in order to do that, we just take 12 squared plus 3 squared plus 4 squared, square root that. And I think that would give us 13 if we do that in our calculator. Anyway, so that's going to be what u is. And then we can find the u hat by dividing each one of these. So it would be like 12 divided by 13 for the first x component. And then the next one would be negative 3 divided by 13. And then the next component would be 4 divided by 13. And that's going to give us the u hat. So the next step is a little bit harder. We're going to be doing the duf component here, which is this gradient of f dotted with our u vector. And yeah, so in order to do that, we got to find our gradient, which means we have to find the derivative of this thing. It's a little bit harder, but we'll try it. So let's do fx is over here. If I were to take the derivative of this, it would be something like this. Actually, let's not even worry too much about that, because first we gotta evaluate that. It would be like 1 over 25x squared divided by 9y plus 2z squared right here plus 1. Because this is technically like x squared. This is like x squared if I square everything in there. And then I'm adding 1. It's a little sloppy here, but we're going to write this a million times. So anyway, we got that. Now we kind of want to rearrange this because it looks a little sloppy, but yeah, so let's try doing that real quick. So it would be like it would be this over that, because we got a 1 right there, so you could just kind of multiply that, and then this would turn out to be 25x squared plus 9y 2z squared divided by 9y plus 2z squared. But this would be over 1 up here. And so we have to take the reciprocal. So get 9y plus 2z squared on top divided by the 25x squared plus 9y plus 2z squared on the bottom. Okay, so that's going to be the answer to this first thing. It's a little bit sloppy here, but yeah, so that's going to be what we get for like the general derivative, but remember we have to also take the derivative of the inside with the chain rule. So depending on whether it's going to be the fx derivative or the fy or the fz, we're going to come up with different like coefficients to multiply this for, So on this side, on the fx side, so 9y plus 2z times the derivative of the top, which is 5, minus 5x, and then times the derivative of the bottom, which would actually just be 0. And then we're going to square the bottom, so 9y plus 2z squared. Okay, so that would be the kind of the fx version. We're going to multiply that by this. So on top we would have 9y plus 2z times 5. And on the bottom there's like this 9y plus 2z squared. Notice how those things would cancel. In the fy component, we would have similar results, I think, but let's see. I guess it would be, like if it was 1 over x, it would be negative 1 over x squared, but we'll just go 9y plus 2z, square that. And of course the top isn't really a 1, it's a 5x, but we also have to multiply it by the derivative of the bottom side because it's a chain rule thing. So on the top side we would actually get 9. So it would be negative 45x on top, basically. And then we kind of do the same thing for the z component, and we would get, again, negative 5x divided by 9y plus 2z squared. And then we also want to multiply by the 2 because we're taking the partial z here. Okay. So this would be negative 45x divided by 9y plus 2z squared. And this one would be negative 10x over 9y plus 2z squared. All right. Notice how in every one of these, this top side will cancel with this bottom side. So you're going to be left with only the top sides. And so if we were to try to get this down here, it would be something more like 9y plus 2z times 5 divided by 25x squared plus 9y plus 2z squared on the bottom for fx. For fy, it's just going to be negative 45x divided by 25x squared plus 9y plus 2z squared. And then for fz, it's just going to be negative 10x divided by 25x squared plus 9y plus 2z squared. Okay, and then all we need to do is we need to kind of multiply this by the u hats. So that would be these. And we're just going to put them like right here in front, like next to them. So 12 divided by 13 is what we would multiply that by. And this would be negative 3 divided by 13. And this thing would be 4 divided by 13. And then we want to stick in our coordinate points too, because we're looking at 7, 0, 0. So that's what we're going to plug in here. Now, let me see if I could try to like find a little space here to add this in. Because you'll notice that fx would be equal to like 0. And so you would know that duf is going to be equal to this, right? The dot product. So it's here we're just going to place 0 because that's the dot product between this. Notice this is a y and a 0, a y and a z on top, and they're just zeros. And so if you're just going to get 0 on the top, it's just going to be 0. But over here it's jj. So like let's get this. If you plug in 7, you're going to get 7 on top. So that's nice. So what we could do on here is going to be kind of like negative 45 times the 7 that we have on top. And on the bottom, we'll have the 25 times the x squared, which is 7 squared. And then there's just going to be another 0 here, so that's all we need. So in that component, we're going to get negative 9 over 35. Okay, and then in this final component here, we're just going to do negative 10x on top It's negative 10 x, so it'll be negative 10 like this on top. And then over here you get 25 x squared. Again, which is just like that. So here you get negative 2 over 35. Okay, so we're getting somewhere. And the last thing we need to kind of do is to remember multiply it by these little coefficients. I forgot to do that. So we'll put that in there real quick. That was just 1j. Yeah, kind of messed this up here. But let's throw in the next j, which is the u. Okay? So on the next line here, duf is supposed to be equal to, we'll go negative 9 over 35 times, what's the u over there? That u is negative 3 over 13. So what's negative 9? Negative 9 over 35 times negative 3 over 13. It's actually 27 over 44, not 55. So 27 over 455. And then for this part right here, that vector is this one. So I'm going to do this like negative 2 over 35 times 4 over 13. And now we get negative 8 over 455. And so the final answer, if we add those two up, 27 over 455 plus, well, minus 8 over 455 is just going to be 19 over 455. And there we go. That is going to be the final answer for DUF. It's a little bit difficult to find these